Hello friends, Eli Hibit here with the Pwn Your Homework Physics Series podcast. If you're looking to prepare, review, or gain an added edge or point of view about topics in physics, then look no further. Tune in each week to unlock your understanding of the physical world surrounding us. And now let's dive right in.
Hey, how is everybody feeling today? I am your host, Eli Hibit, back at you again with another episode of the Pwn Your Homework Physics Series podcast, and this week's edition is entitled episode number 81, Physics Brushup Review Volume 2. So, last week, episode 80 was Volume 1, where we went through, Greek letters, units of measure, powers of 10, and the like. So, if you haven't yet, I would definitely go back and check that one out. And then, we will press ever onward here. We're going to go through coordinate systems, sines and cosines, Sohcahtoa, vector components, and vector operations. So no shortage of material to talk about today. But first, let's take an eye and turn it to the sky. Today, the moon phase, we have 29% illuminated waxing crescent. And the full moon is coming in 8 days. And we will also have a new moon in 24 days. 8 days. So we are going to be right on the edge of full moon for Christmas. Well, Christmas Eve, I guess. So that's cool. Hopefully by that time, your woes will be over and you'll be resting and recovering and feeling good. So, all right. Anyways, let's, without hesitation, dig in. If you have not, I encourage you to go check out the Twitter account, PWN Physics. A lot of info snacking over there. Lots of facts and factoids about physics that are relevant to your first year journey. So check us out over on Twitter, and also the blog, pwnyouRHW.blogspot.com, with all the lovely show notes and links that are contained therein. So we're going to kind of follow the same format as we did last time. Each topic we'll talk about a little bit and then go through some questions, and then we'll wrap it up and get you out of here. So first, coordinate systems. Let's do the questions first, I guess. Which coordinate system has points which can be represented by the positions x, y, and z? That would be, of course, a 3D Cartesian coordinate system. All orthogonal, 90 degrees to each other, and it kind of looks like a jack, I guess you'd say, across, and then with a third dimension in it. And Cartesian 2D is just our standard, coordinate system that you've probably seen a million times, and it's just usually XY axis. So we have XY, but if we go 3D, then we use XYZ to represent our random point in space. Question number 2, which coordinate system has points represented by the positions r, theta? And that would be polar coordinates. We sort of assume that everything rests on a sphere or a circle, I guess you'd say, since it's 2D. It is, of course, 2D. And so we can describe the radius and then the angle with respect to our so-called x-axis, theta. And you can describe any point that way. So very convenient when doing a lot of different trig operations. So that is pretty much coordinate systems. You need them for basically every problem that it deals with motion, which is pretty much all of them. And so yeah, very important to know your coordinate systems. You got your spherical, you got your polar, you got your Cartesian 3D and 2D, and there are some other ones, but those are the major players. So coordinate systems. Sines and cosines by counting to 4. Do you remember the trick? Actually, let's dig back into the archives here. This, man, if you didn't check out this episode, I would say I thought this was the coolest thing ever. If you can count to 4 and you can know the sines and cosines of 0, 30, 45, 60, and 90 all the way around by counting to 4, man, is that powerful. So let's see. Let's look back in the archives here and see, where did I land on that? That's an old episode. I'm not even episode 28. No. Episode number 25. Signs of sines and cosine and understanding quadrants. Was it before that? Episode number 24, sines and cosines by counting to 4. So that is a very old episode, but that one I recommend you go back and check out if you're not up on the old sines and cosines. So here we go. Well, let's see how up you are. Question number 1, what is the sign of 0? Of course, the sign of 0 is 0. What is the cosine of 0? Cosine of 0 is out of phase, 90 degrees of sine, and so the cosine of 0 is 1. Question number 3. What is the sine of pi? And sine of pi is, of course, also 0. So, yeah, sines and cosines by counting to 4. If you take your sine of theta is equal to square root of x over 2. Your square sine of 0 is 0 over 2 is 0. Then 30 degrees is square root of 1 over 2, which is 1/2. 45 degrees, square root of 2 over 2. 60 degrees, square root of 3 over 2. And then 90 is square root of 4 over 2, or 1. So, yeah, if you don't, a little quick brush up for you here, but if you don't have that down pat, go back and check out episode number 24, the sines and cosines by counting to 4. 10 minutes is all you need to master that. So, with sines and cosines in hand, let's push forward to Sohcahtoa, which was the next topic we covered in the series here. And so that was episodes number 27, episode number 30, Wardenclyffe Tower. Episode number 31, Sohcahtoa, sine, cosine, tangent, and the right triangle. Then we did a Sohcahtoa pop quiz. And episode number 34, 6 steps to applying Sohcahtoa to any right triangle problem. So, without further ado, Sohcahtoa. Which trig function is the ratio of opposite to hypotenuse sides of a right triangle? So, opposite over hypotenuse, OH, SOH, the answer is, of course, sine. And, of course, that's what Sohcahtoa stands for. Question number 2. The tangent of an angle is equal to the ratio of which two sides of a right triangle? So, tangent, TOA. So, is the ratio of the opposite to the adjacent side. TOA, tangent equals opposite over adjacent. So, yeah, check out, go back into the archives and grab those episodes if you need a little Sohcahtoa brush up. And then, so with Sohcahtoa in hand, we press forward to components, vector components. And so the first question, how is a vector component related to a vector? So this does not have a, hard and fast, answer. But the vector component is, we sort of think of the vector as the hypotenuse of a right triangle, and then the components are the legs of that triangle, especially in 2D space. And so we can use our Sohcahtoa rules. Well, let's see. Which identities or functions allow us to break vectors into components? Did I give it away? Of course, Sohcahtoa, or trigonometric functions, allow us to break vectors into components. So if we want to know, we have our vector, we want to know the y component, then, we take our vector times sine theta, and the x component is times cosine of theta. In 2D space, you have your components right there. So let's take a look at the old feed here, and let's see where did we wind up hitting that? Vector components, example number 1, episode number 44. Episode 43, 5 steps to break any vector into components. Episode number 42, 5 critical vector properties for components and the importance of coordinate systems on vector operations. There's 15 minutes of your life that you're going to want to spend. So there we go. So once we have components, this is kind of like a quick way to do calculations, and it's not you're not cutting corners, it's how you do it, but it's sort of a direct application of a general idea, which is, of course, vector operations. And so here I got 5 questions, and we've been going through this. This is the most recent stuff we've been doing on the show. And where do we have that? We're going episode 70, episode 71, cross products, episode 72, right hand rule, episode 73, cross product example, part 1. So that's where you're going to want to look in the 70s, and maybe even, the 70s, if you want to take a look at the dot and cross product examples and all of that vector stuff. So here we go. Let's test your knowledge. Question number 1, how do you add vectors? By adding vectors, you add like components of each vector. So, if you have vector v and vector w, you add vx plus wx. and Vy plus Wy, and Vz plus Wz. And then that is your added vector. Question number 2, how do you subtract vectors? Much in the same way, you just subtract the components of all of your components. So, in that we have Vx minus Wx and so forth through x, y, and z. How do you multiply vectors? This is a kind of a trick question, I guess. So you have two different options here. Multiply vectors is not a straightforward thing. If you want to do a vector multiplication, you can either yield a scalar, which is called the scalar or dot product, or you can get a vector, which is known as the vector or cross product. So that leads us right into question number 4. How do you perform a scalar product? So much like addition and subtraction, we are going to multiply together like values in each of the component directions, I guess you'd say. So Vx times Wx, for example, and we'll do that so forth and so on. And now you don't have to have only a three-dimensional vector. Because we live in 3 spatial dimensions, we usually wind up existing that way. But if you look at string theory, I mean, we're up to 26 dimensions, something like that, spatial, theoretically, And so you can have, a zillion dimensions. You can have as many dimensions as you want in this vector, and then you just multiply each component like that and add them all together. That's the next step. So after you've taken all of your products and you add them together, and that is your scalar product. Box your answer and you're done. And so sort of the different way, question number 5, how do you perform a vector product or cross product? So this kind of goes back to the determinant. So for each component, you're going to calculate your small determinant of the matrix, which does not include the dimension with which you are doing the operation. So for the I hat or x direction, you're going to have Vy times Wz minus the quantity Wy times Vz. And then we do that for each of the subsequent directions. And then you have your resultant 3D vector product. So if you want to dig into the details of that, which episode can I direct you to? Let's see. Episode number 62 is vector addition of 3 distances. Episode number 70, the determinant. And then episode number 71, the cross product in 2 and 3 dimensions, where we definitely went into that in extensive detail. And that's only a half hour if you want to dig into those 2 episodes. These 15-minute chunks, I think, do a really good job of keeping everybody interested. So there we go. Coordinate systems, sines and cosines, Sohcahtoa, components, and vector operations. So yeah, those a great many of those topics are covered in my Physics Brushup bundle available on the App Store. We have our step-by-steps, examples, and flashcard reviews for each module there. So do check it out. Head over to PWNYOURHW.blogspot.com and head into the App Store and see all of the glorious physics review tools which await you. So I think that's gonna do it. I'm gonna try to do a volume 3 where we're gonna press onward. Calculus, lines, and parabolas is what we have left in terms of a boot camp style, and then that should take us to episode number 100, and then we're gonna dig into kinematics, force, and really be getting into it there. So that's what we got on deck. But until next time, guys, stay frosty, stay in the zone, and I'll catch you next time. Take care.